In this video, I am going to explain LED's bar graph. Important sketches are here. Consider 10 LEDs. Here we use 10 LEDs. Select 10 pins, 10 digital pins. Then digital pins from Ardunio. The digital pins are from 13 to 13, 12, 11, 10, 9, 8, 7, 6, 5, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pins. And one more important device we have to choose is a potentiometer. Potentiometer, 10 kilo watt potentiometer, and the LEDs, 10 LEDs, and Arduino board. With the help of that Arduino board, I have to choose the digital pins. These 10 digital pins. These 10 digital pins are connected to 10 LEDs through resistances. 10 220 ohms resistances. 10 220 ohms resistances. These are the components will require. Study this experiment. First one, sketch. Declaration. Here we use a potentiometer. Potentiometer, generally the potentiometer has 3 terminals. Terminal 1, terminal 2. This one is middle terminal is Viper terminal. The Viper terminal is treated as a potentiometer pin. Potentiometer pin. The Viper terminal is treated as potentiometer pin, and this one is potentiometer value. Potentiometer value. P capital. 10 bit analog to digital converter is there. Resolution is 2 power 10 means 0 to 1023 values. That means 0 to 5 volts are mapped to 0 to 1023 values. This is a some important description of the potentiometer. How to define this potentiometer value and potentiometer pin. Integer potentiometer value. Initially that potentiometer value is 0, less than 0. Next, integer potentiometer pin. Initial potentiometer pin is equal to A1. Next, one more important thing we'll define here is integer I. Next, coming to here 10 pins, we have to define 10 pins in void setup. This one is void setup. Void setup. Curly bracket open. Generally we use for loop. For I is equal to 13th pin. I greater than or equal to 4. I minus minus, I minus minus. That means 13. I minus minus means 12. 13 less than 4. 13 greater than 4. And 13 changes to 12. 12 greater than 4. 12 changes to 11. 11 greater than 4 up to 4. That means 10 digital pins. In pin mode, I output. These 10 pins are defined by using this for loop. And one more important parameter a device defined here is a potentiometer pin. Potentiometer pin, analog potentiometer is an analog device. That is the reason we use pin mode. Input one. A1 is the analog pin and input. Why this one is input? Because by changing these values from 0 to 10,023, LEDs are gradually on. Stage 1, we have to choose these values in different 10 intervals. In first interval, all are clear, or LEDs are 0, not on. In that first interval, 0th interval. In first interval, 1 LED is on. In second interval, 2 LEDs on. Third interval, 3, 4, 5 up to 10 LEDs. By using these values 0 to 1023, the value LEDs are on. Like first case, clear state. Next, first LED is on. Second LED is on. Third LED is on. In the first LED, the range is 0 to 103. 104 to some value 2006, like that. By using these values, you have to glow the LEDs. That is called as LEDs bar graph. Now I am going to write the sketch related to our action. Next one, serial begin, SERIAL, S is capital, serial begin 9600, that is the baud rate or bit rate. These are the this curly bracket, closing curly bracket for this opening curly bracket. We need another closing curly bracket for this one, void set. Next one, read potentiometer values from 0 to 1023. In that case, we use the analog read. Already integer potentiometer are declared at the beginning. Suppose the declaration is not there at the beginning. Here we use integer in front of potentiometer. Potentiometer value is equal to analog read. These values are changed by using a potentiometer wiper pin. Potentiometer pin. These values are displayed by using a serial display with the help of this function, serial monitor. Serial dot print numbers. These potentiometer values are displayed 0 to 1023. Potentiometer value. Okay, now start. First, initially all LEDs are in 0 mode, off mode. By using this one, I have to write this one. So many ways are there. I will follow this way. If 0 to 1023, if potentiometer value is equal to 0, curly bracket open. For I is equal to 30, I greater than or equal to 4, I minus minus. Digital write, all these are from 13 to 4 are digital pins. You have to use digital write, high, low. Low means all LEDs are on off condition. That is the clear state. Now, if the potentiometer value is choose, and then we have to assign something. Now, second declaration is if potentiometer value, if two brackets here, potentiometer value greater than 0. 0 already completed, greater than 0, and potentiometer value less than 103. Choose any value. Potentiometer value less than 103, two brackets here. In that case, the first out of 13 to 4 digital pins or LEDs, 13th pin is assigned to first LED, 12th pin is assigned to second LED, and so on. Therefore, first LED, that means 13th pin is assigned to first LED, that must be on. On means digital write. 13th pin is assigned to first LED, that must be high. Delay is 100 seconds, 100 milliseconds. Again, we use for loop. For 13th pin is completed, first LED is completed. For next LED, second LEDs. For second LED, 12th digital pin is assigned to second LED. From 12th onwards, from second to 10th LEDs is in off mode. Off mode means again I greater than or equal to 4, I minus minus. Digital write, I low. 13th pin is assigned to first LED, that is in on condition. The remaining pins from 12 to 4 pins are assigned to digital pins of the Ardunio board are assigned to second to 10th LEDs are in off condition. Two curly brackets. Next, 0 completed, potentiometer value 0 completed up to 103 completed. From 104 to 206. From 104 to 206. Here are some 104 to potentiometer value from 104 to 206. You choose randomly these values. If potentiometer value is greater than 103, that means 104, and potentiometer value less than 206, that means 104 to 205. 206, two brackets close. Already 30th pin is high. Now 12th pin is in high condition. Therefore, we use digital write. 12th pin is in high condition. Delay 100 milliseconds. Again, the 13th completed, 12th completed. Next, from 11 to 4, that means third LED to from 11th pin to 4th pin, the LEDs are in off condition. for I is equal to 11, I greater than or equal to 4, I minus minus. Digital write, I low. Third LED to 10th LED. Third, 4th, 5th, 6th, 7th, 8th, 9th, 10th. These LEDs are in off mode. Next one. 206 value completed. Next, if the potentiometer value is greater than 2062, if the potentiometer value, next step is if potentiometer value greater than 206, that means 207, and potentiometer value less than 406. Now curly bracket open, digital write, here values are here greater than 206, less than, here some value is wrongly mentioned, 303 here, 303, digital write, 11th pin, 12th pin high completed, 3rd pin, 11th pin is high, delay 100 milliseconds, delay 100 milliseconds for I is equal to 10, I less than or equal to 4, I minus minus, digital write, I low. 11th pin is also completed. This one is I11. This one is I11, 12, 11, 10. Next one is the potentiometer value. If potentiometer value greater than 303, less than 303 completed, and potentiometer value less than 406. Digital write, 10th pin is high. Digital write, 10th pin is high. Delay 100 milliseconds for I is equal to 9, I greater than or equal to 4, I minus minus, digital write, I low. Okay. 4 LEDs. The next one, if potentiometer value, potentiometer value is greater than 406 and potentiometer value less than 512, digital write, 9th pin is high. Here 10 means 13, 12, 11, 10, 4 LEDs are on. Next 5th LED, that means 9th pin is assigned to 5th LED. Digital write, 9th is high, the remaining are half. Delay 100 milliseconds, for I is equal to 8, I greater than or equal to 4, I minus minus, digital right, I low. Next one, 512 up to 512 completed, 5 LEDs are on. Step by step, bar graph is up to 5. Next, if potentiometer value greater than 512 and potentiometer value less than 620, digital right, eighth pin is high, delay 100 milliseconds. The remaining pins are off. For I is equal to 7, I greater than or equal to 4, I minus, digital right, I low. Next, the potentiometer value, if potentiometer value greater than 620 and less than 740, curly bracket open, digital right, seventh pin is high, delay 100 milliseconds. For I is equal to 6, I greater than or equal to 4, I minus minus, digital right, I low. Next one, three more LEDs are there. If potentiometer value greater than 740 and potentiometer value digital right, sixth pin is assigned to some LED, delay 100. From fifth pin to fourth pin, the LED is in off condition. I is equal to 5, I greater than or equal to 4, I minus, digital right, if potentiometer value greater than 840 and potentiometer value less than 940, digital right, fifth pin is high, that means ninth LED is in high condition, delay 100 milliseconds. For I is equal to 4, I less than or equal to 4, I minus minus, digital right, high, low. Last one is the remaining one. The remaining means a 940 to 1023. If 0 to 1023 values are divided into 10 intervals, the step-by-step intervals are allocated. This is the last one. Potentiometer value greater than 940 and potentiometer value less than 1023. Digital write. Only fourth LED is in a high condition. Last LED. Delay 100 milliseconds. Delay 100. Okay. 0 to 1023 is divided into 10 intervals. For 10 LEDs. Okay, in one interval, one LED is run, in second interval, 2 LEDs, third interval, 3 LEDs, and so on. Last interval, all LEDs are glow or on condition. By changing the potentiometer knob value, these LEDs are glow from left to right. Now we will see the demonstration on this experiment by using some TINKERCAD. This one. Pins selected are 13, 12, 11, 10, 9, 8, 7, 6, 5, 4. These are the digital pins. These digital pins are declared by using this one. These digital pins. For I is equal to 13, I greater than or equal to 4, I minus means 13, minus 1 means 12, 12 minus 1, 11, 11 minus 1, 10, 10 minus 1, 9, 9 minus 1, 8, 8 minus 1, 7, 7 minus 1, 6, 6 minus 1, 5, 5 minus 1, 4. Pin mode I output. These are the pin modes up to 4, 13 to 4 defined in that code is like that. One more device is the potentiometer here. Potentiometer has 3 terminals. This is the terminal 1. This is the wiper terminal. This is the terminal 2. Terminal 1 is connected to ground. Terminal 2 is connected to 5 volts. Ground and 5 volts are made on the breadboard from Ardunio, Ardunio. This is the 5 volts. This is the 5 volts line. This is the 5 volts line. Here made here. 0 volts line, that is the ground line made here. These are the 10 LEDs. 1, 2, 3, 4, 5, 6, 7. Cathodes, all cathodes of the LEDs are connected to ground. All anodes of the LEDs are connected to digital pins of the Arduino boards from 13 to 4 through resistances, 220 ohms resistances, 10 to 20 ohms resistances. By changing this potentiometer value, the LEDs are on from left to right. In one interval, first LED is on. In another interval, 2 LEDs on. In another interval, 3 LEDs, 4, 5, 6, 7, 8, 9, 10 LEDs are run. Based on that, this potentiometer values 0 to 1023. This is the description of the circuit. Already the code is explained. This is the code. This is the code. In this range, in the 0 potentiometer value is 0, all LEDs are in off condition. That means digital write from 13 to 4 pins, digital pins are assigned to 1 to 10 LEDs are in low condition. If the potentiometer value is greater than 0 and the potentiometer value less than 103, by changing this wiper value, rotate this one, the values are changes. See how to change the values in the serial monitor with the help of this one, serial dot print numbers potentiometer value. With the help of this statement, monitor these values. Potentiometer value, we use the analog read potentiometer pin. The pin changes, the potentiometer values are also changes. These values are displayed on serial monitor with the help of serial dot print values. That is the potentiometer values. These potentiometer values are changes 0 to 103, 103 to 104 to 206 like that. The LEDs are on. Previously, in the explanation part, I have clearly explained these values. Here 940, here we use 940, 840 to 940, 740 to 840, 622, 740, like that. In different intervals. Digital write 13th pin is high means first pin is high. In this analog values 0 to 103 values, the remaining pins 9 to 4, the remaining LEDs in that interval 0 to 103, the first LED is on. That means 13th pin is assigned to first LED anode. Okay, that is the reason digital write 13 high. The remaining LEDs are off condition. Assign 12 to 4 pins are in low. That means digital write high, low. In this way, 30 first LED is okay. Next second LED. In this 102 to 206, the second LED is high. This is the second LED is high. The remaining 3rd to 10 LEDs are in low. Third LED means for third LED, 11th pin is assigned. Last LED, 10th LED, 4th pin is assigned. In this way, all LEDs are clearly defined here. Now we will simulate. See the simulation. Start simulation. This way, this first LED is on, second LED is on, third LED, fourth LED, fifth, sixth, seventh, 8, 9, and 10. In this way, the LEDs are in off condition. See this one. By using that code, by using that serial monitor. This is the serial monitor. Start simulation. The values are displayed here. 0, all LEDs are in clear, off mode. By changing this value, first LED is on. These values up to 1 or 2. By changing this value, second LED is on. Up to 206. Okay. Third LED is on. Third, fourth, fifth, sixth, 7th, 8, 9, 10. In this fashion, by changing this potentiometer values, the LEDs are on and on. The LEDs on condition depends on the potentiometer values from 0 to 1023. With this simulation, the demonstration of this sketch, Bargraph LED sketch is completed. If you like this video, please subscribe the channel for further updates. Thank you.